Hello everyone. This is a short lecture on infrastructure as a code. We will discuss the basic concepts of IaC and perform some basic configuration in this lecture to get the ball rolling. Now let's get started. So what is infrastructure as a code? So IaC is the process of managing infrastructure in a file or files rather than manually configuring resources in a user interface. A resource in this instance is any piece of infrastructure in a given environment, such as virtual machine, security group, network interface. Infrastructure as a code automates the provisioning of infrastructure, enabling your organization to develop, deploy, and scale cloud applications with greater speed, less risk, and reduced cost. IaC is also an essential component of DevOps practice. It enables DevOps teams rapidly create and version infrastructure. In the same way, they version source code and to track these versions so as to avoid inconsistency among IT environments that can lead to serious issues during deployment. So if you look at the diagram on the screen, on the top there are some templates, scripts, and policies. And at the bottom there are some components like network, application, storage, security, or any other cloud infrastructure components. And the tools in the middle are helping you to write or enable these components with the help of these templates, scripts, and policies. We will look at them in detail in the coming slide. Now let's look at some of the advantages of infrastructure as a code. So the first one is faster time to production or market. So IaC automation dramatically speeds the process of provisioning infrastructure for development, testing, and production, because it quantifies and documents everything. The second is improved consistency. Configuration drifts occurs when ad hoc configuration changes and updates result in a mismatched development, test, and deployment environments. This can result in issues at deployment, security vulnerabilities, and risk when developing applications and services that need to meet strict regulatory compliance standards. IaC prevents drift by provisioning the same environment every time, so which at the end improve the consistency of the system. The third is the faster and more efficient development. By simplifying the provisioning and ensuring infrastructure consistency, IaC can confidently accelerate every phase of the software delivery lifecycle. Developers can quickly provision in sandbox environments. QA, quality assurance, can quickly provision test environments. Operations can quickly provision infrastructure for security and user acceptance testing. And when the code passes testing, the application and the production infrastructure it runs on can be deployed in just one step. The last one is the protection against churn. So to maximize efficiency in organizations without IaC, provisioning is typically delegated with a few skilled engineers or IT staff. If one of these specialists leaves the organization, others are sometimes left to reconstruct the process. IaC ensures that provisioning intelligence always remains with the organization. So you do not depend upon your skilled engineers or IT staffs. It is documented in a form of a template and a policy that can be later reviewed by any of the engineer that is replacing your staff. And there is another one, lower cost and improved ROI, which is the obvious one. In addition to the dramatically reducing time, effort, and specialized skill required to provision and scale infrastructure, IaC lets organizations take maximum advantage of cloud computing's consumption-based cost structure. So it also enables developers to spend less time on plumbing and more time developing innovative mission-critical software solutions. Now, there are some important concepts in terms of IaC that we need to understand before we jump into the console for some configuration. So the first concept is the immutable versus mutable infrastructure. So let's look at the mutable infrastructure first. In the mutable infrastructure, the infrastructure can be modified or updated after it is originally provisioned. Mutable infrastructure gives the development teams the flexibility to make ad hoc server customizations or to say very closely fit development application requirement to respond to an engagement or a security issue. But it also undermines a key IaC benefit, the ability to maintain consistency between deployments or within versions, and can make infrastructure versioning track more difficult. So if you look at the diagram in here, the mutable infrastructure in the first phase, which is the app 1, there are some services installed, and the version of this services is 1.0. Later on, there are some configuration changes made onto the app that is specific to that app. For example, service 1.1, service 0.9. So this basically is a kind of a mutable infrastructure where a specific application is customized, which is unique in nature. Now, in comparison, what is immutable infrastructure? That for IaC implemented immutable infrastructure that cannot be modified once originally provisioned. If mutable infrastructure needs to be changed, it has to be replaced with a new infrastructure. It all eliminates configuration drift and makes it even easier to maintain consistency between test and deployment environment. It also makes it easier to maintain and track infrastructure versions and to confidently roll back to any versions when necessary. So if you look at on this diagram, there is an app, and you need to make some changes in this app to customize this application. So once you deploy the app 2.0, it will completely replace app 1.10, and you can always fall back to app 1.0 whenever required, because the versioning control is in practice. So you were on 1.0 and later on 2.0. Once you want to switch to 1.0 back, you just execute that template or a policy, and the infrastructure will be deployed accordingly. Now, another important concept in reference to infrastructure as a code is the imperative or procedural versus declarative approach. So this means that how do you deploy your infrastructure? What is the methodology that the infrastructure tools or IaC tools uses? So let's look at them. In the first one, in the imperative approach, also known as the procedural approach, the solution helps you prepare automation scripts that provision your infrastructure one specific step at a time. While this can be more work to manage as you scale, it can be easier for existing administrative staff to understand and can leverage the configuration scripts you already have in place. So in the imperative model, you explicitly define the instruction, and the system basically does not know anything. It depends upon your smartness to deploy a specific type of a system with explicit instructions. Now, in comparison, the declarative approach, also known as the functional approach, is the best fit in the kind when you specify the desired final stage of the infrastructure and you want to provision, and the IaC software handles the rest. So which means that there is a final configuration, a specific configuration that you want to deploy for a firewall or a virtual machine. You will define that final stage in the declarative approach, and the system or the infrastructure as a tool is smart enough to identify what different steps need to be taken to reach to that outcome. So spinning up of a virtual machine, container, installing and configuring the necessary software, resolving system and software interdependencies, and managing versioning, all of is being done at the back end with the help of that infrastructure as a core tool. So the chief downside of the declarative approach is that it typically requires a skilled administrator to set up and manage, and these administrators often specialize in their preferred solution. Now, the next is a comparison between different popular IaC tools present in the market. So if you look at it, the main popular IaC tools, or I should say configuration management tools, because they're very closely related to each other: Chef, Puppet, Ansible, SaltStack, CloudFormation, and Terraform. Let's look at what is the difference between them. So from the code perspective, all of them are open source tools except the CloudFormation, which is basically developed by AWS. In terms of the cloud, all of them supports multi-cloud environment except AWS, because CloudFormation was developed by AWS itself. Now, in terms of the type, what it can handle, so there are two types of these IaC tools: the configuration management tool and the orchestration tool. So what is the difference between them? So Chef, Puppet, Ansible, and SaltStack are all configuration management tools, which means that they are designed to install and manage software on existing servers. While CloudFormation and Terraform are orchestration tools, which means that they are designed to provision the servers themselves, leaving the job of configuring those servers to other tools. Now, we have to understand that there is a slight overlap between configuration management and orchestration. So the orchestration tools can do some sort of configuration management as well. In the same way, the configuration management tools can do some sort of orchestration as well. But if you're looking for a typical infrastructure provisioning tool, then you should ideally look for the orchestration tool. While if you are looking at maintaining or managing the software that is being installed and would like to do a versioning control on that, then you should look for the configuration management tool. Now, in terms of infrastructure, the configuration management tools are Mutable, and the orchestration tools that are presented in here are Immutable. Now, in terms of the language, some of them are procedural and some of them are declarative. We have already spoken about the difference between these two of them. The tool that we will be looking at is the Terraform tool in this lecture, which takes the declarative approach. Now, in terms of the architecture, which is also very important, if you look at the configuration management, they are client-server based, so they require a server, while the orchestration tools, CloudFormation and Terraform, they are only client-based. Now, let's look at what is Terraform. Terraform is one of the most popular tool that is being used for provisioning the infrastructure resources in the market. Terraform is an open source infrastructure tool created by HashiCorp. It enables users to define and provision data center infrastructure using declarative configuration language. It is easy to learn and can integrate with all major cloud providers, including AWS, Azure, and GCP. So let's now go to the console and start installing the Terraform product and then provision some resources. So let's do Terraform client installation on a Windows machine. Open PowerShell as an administrator. And I'm getting a message. I'll press yes. Then I will copy the command, which is the software package chocolatey that will help us install the Terraform. I'll put the file on a shared folder so that you can apply this command into your systems as well. So I'll just paste that command, paste, and it started to get install the chocolatey software. The software installed. Now I have to install the Terraform client. This is the command choco install Terraform. I'll go to the PowerShell. I will paste this command and I will press enter. The installation is in progress. Yes, the installation is in progress. In a few moments the installation will finish. As you can see, it's now 100%. And once the application installation is done, then we will be able to run the Terraform commands. Now the application installation is done. So if I write Terraform space version, I can see that the version of the Terraform is 0.13.0. So this is the installation of a Terraform application client on a Windows 10 system. Now we will start looking at some of the configuration to provision infrastructure on a cloud environment, specifically AWS. So let's look at some of the basic commands of Terraform that we will be using in the upcoming section. So the first command is Terraform init. So the Terraform init command is used to initialize a working directory containing Terraform configuration files. This is the first command that you should be running after writing a new Terraform configuration or cloning an existing one. It is safe to run this command multiple times. The second command that we have is the Terraform plan command. Now this command is used to create an execution plan. This command is a convenient way to check whether the execution plan for a set of changes matches your expectations without making any changes to real resources or to the state. For example, Terraform plan might be run before committing a change to version control to create confidence that it will behave as expected. Now the next command is Terraform apply. The Terraform apply command is used to apply the changes required to reach the desired state of the configuration or the predetermined set of actions generated by a Terraform execution plan. And the final command is Terraform destroy. The Terraform destroy command is used to destroy the Terraform managed infrastructure. Now let's start with a very basic lab. Now in this lab we will configure Terraform to launch an EC2 instance on the AWS, and then we will verify it from the AWS console that this EC2 instance has been launched successfully. Later on we will do a case study, which is a comprehensive exercise in which we will enable many different components of AWS through Terraform. But let's start with the basic exercise where we are launching an EC2 instance. Now our instance is live. Now the last step that we have to do is to destroy the instance from the Terraform command line. So what we type is Terraform destroy, and it will ask you for a confirmation, and then we'll press yes, and it will destroy the EC2 instance. If you can see in here, our instance is still live, right? And then we'll go to the console again. It's asking for confirmation, 0 to add, 0 to change, and 1 to destroy. We'll press yes here, and it will start destroying the EC2 instance. So it will bring us, all the changes that we have made. Basically there was only one change, that we deployed the EC2 instance. The EC2 instance will now be terminated. So I'll stop the recording in here, as it will take some time to destroy the instance. Now as you can see, the Terraform has destroyed the instance, and destroy complete, resources 1 destroyed. Let's go into our console and double check that. So as you can see, the instance has been terminated now. So this is a Windows 10 machine, as you can see, and this is the same machine in which we installed the Terraform client. So to start coding for Terraform, I'm using here Microsoft Visual Studio, but you can also use Notepad. This Microsoft Visual Studio is a free tool, and it's very comprehensive tool when you're doing a coding exercise. It's very convenient to use. Now what happens is that we start with the Microsoft Visual Studio. I'll open a folder. Here I'll create a new folder, and I will name it EC2 lab. I will open this, select folder. Now inside that folder I'll create a new file, and I will name this file, save as EC2 lab.tf. So TF is an extension of Terraform. So now we have a file created in here. Now I will start putting in some configuration in here. So the first configuration that we have is the provider configuration. So let me copy from here and paste it in here. So this is the provider configuration. This configuration basically tells you that which provider you are working with. Either it's AWS, it's Azure, it's GCP, it's Oracle. So this is the first configuration that is going in here. So provider is AWS, profile is default, region that we will be configuring in will be US West 1, and this is the access key and the secret key that you are defining in here, which will help us access the AWS APIs. And how do you create these access keys and the secret keys? Let me show it to you. So you go into the AWS console, you click on your username and here IAM, we open it in a new tab. You go to users, you go to any of the user, or the user that you have created for yourself, and here in the user you go to security credentials, and here you can create the access key. So press on creating the access key, and you can, let me create one, so download as a CSV file and close. So there are two access keys created in here, so I will just deactivate them, make inactive, make inactive. Now let's go back to the console, and here are the access keys and the secret keys defined in here. Now the next configuration that we have is we have to launch an EC2 instance. So for that there is a configuration, define EC2 instance, copy here and paste, and you save that file. Now defining an EC2 instance is resource is AWS instance, and the name is EC2. The AMI that we'll be using in here, this is the name of the AMI, this is a Linux AMI. Instance type is T2 micro, and the associated public address is true, which means that once the EC2 instance is up, the public IP address will be assigned to it. Now one of the questions is, how am I coming up with all this configuration? Do you have to learn this configuration? No, not at all. Everything is from the Terraform documentation, and it's very easy to pull up. So let me go to Google and try to show you how I do this configuration. So Terraform, I'll write Terraform AWS provider config, and if you look at it, let me open this documentation from this one. Open new tab, and if you look at it, if you go to the configuration below, here's the configuration. This is the same configuration which I copy pasted. This was for Google. If you go down little bit below, you will find the AWS configuration as well. Same is for the launching the EC2. Now you want to launch an EC2 instance, you can write Terraform AWS EC2 instance, and then you can find a number of documents in here showcasing how to launch an EC2 instance in here. So everything what I'm doing in here is a copy and paste from the Terraform documentation. The only thing that I have changed is the variables, which is, for example, the AMI available in the US West region. I have changed it. Instance type T2 micro. So you just have to change the variables and you can launch the instance. So you don't need to remember anything from this perspective. Just think about what you have to do. You have to define a security group, you have to enable a firewall, you have to do a load balancer, and all of this you just put it on the Google, go to the Terraform documentation, and from there you can copy and paste the configuration, just change the variables. Now after that, I'll go to the terminal in here. Please make sure that you are in the same folder as the configuration file. So we are in the C Terraform EC2 lab, and this is the same place where the configuration is. Let's test this. So if you look at it, this is the file that is ec2lab.tf. Now the first command that we learned was the Terraform init. So what this will do is that this will download all the plugins that are related to AWS and are required to apply this configuration onto AWS. So now, as you can see, this is downloading the different plugins related to that. The plugins are successfully downloaded. The next command that I will do is the Terraform plan. So as we know, the Terraform plan is an offline execution where it will review your configuration, which is currently presented in front of you, and will showcase to you what will exactly be done. So what it's saying at the bottom is plan 1 to add, 0 to change, and 0 to destroy. So there will be one configuration that will be added. And if you look at from the top, it will tell you all the steps that will be done, in terms of deploying this configuration or enabling this configuration on the AWS console. So now the next command that we have is the Terraform deploy. With this Terraform deploy command will deploy the configuration onto the EC2, onto the AWS console. So let's go to the console a bit and see this is the EC2 console for my US West region. Let me just double check. So this is the US West region, and here what I'll do is that there are no 0 running instances. I'll just click on the running instances and I'll see there are no instances running now. So what I'll do is I'll go to the terminal and I'll say Terraform apply. Now it's applying the configuration. It will ask you for a confirmation that are you sure you need to apply that, and I will say yes. And here it's applying the configuration. I'll stop the video for a minute until the the configuration application is done, and then we'll continue. So as you can see, the apply is complete. Resources 1 are added, 0 changed, and 0 destroyed. Now it's time for us to go back to the AWS console and see if the EC2 instance is live or not. Let's refresh this, and as you can see, there is an EC2 instance live in here. So this is how. Now let's work on a case study. This case study will give you a better idea of how Terraform can be used for different environments. So let's read the case study. Primos is a fashion retail store. Company is exploring a new technology to host their web services. You have been asked to deploy a Linux server in AWS with Nginx software to initiate the proof of concept. The POC team may require multiple deployments of the infrastructure to test different use cases. You have decided to implement POC environment via Terraform. This will help you speed up the infrastructure provisioning process with minimal effort. So let's look at the diagram that we are trying to deploy. So if you look at it, there is a VPC in here with the 10.0.0.16, and we have 2 subnets in here, production subnet and web subnet A. So production subnet, I have just displayed it for the sake of that there are different subnets in here, but the subnet that we will be deploying in here will be web subnet A. So inside the web subnet A, there is a web server. On this web server, there is an Nginx software, which is a web server providing web services. Then we have an internet gateway in here, which is connected to the internet. So look at this diagram from the perspective that if you have to deploy this infrastructure with Amazon GUI, how would you do that, right? So you have the network security groups. You have to allow HTTP and SSH traffic in there. We will come to it why we have to allow SSH and HTTP. You have to edit your route table. You have to associate your route table with the internet gateway. You have to create the subnets, right? And you have to send your default route to the internet gateway, right? So all of these steps has to be done if you configure this infrastructure with the GUI. So I have just listed down these steps that what needs to be done if you would like to deploy this infrastructure through GUI. So these are the steps. So define the provider as AWS. So basically this is not applicable on the GUI. You just log into the GUI and start configuring. But on Terraform, as you know, that we have to define the provider as AWS. The second step will be that define a VPC, all right? Then define subnet. Add subnet to the route table, right? Define internet gateway. Edit route table with default route pointing to internet gateway. Define NSG. In NSG, all the incoming traffic is blocked. So allow inbound HTTP and SSH traffic. Now we are allowing HTTP traffic because we would like to access the Nginx web server, which is working on port 80, right? And the SSH traffic is required to be allowed because we need to SSH this web server to run a script and install Nginx server, right? So that is why we are allowing SSH traffic to this web server. Then we have to generate keys. Why? Because this is an EC2 instance, and to access that instance, we need the keys. Then the basic step is the define EC2 instance. We have to define a, like in the previous lecture, we have enabled one EC2 instance. Same, we'll enable the EC2 instance in here and add a script to the EC2 instance so that the Nginx server is automatically installed, right? So if you are even working with the GUI, these are the 10 steps that you must take to deploy this infrastructure, this POC environment, right? And if you have another case, then you have to deploy and do all of these steps again. And you have 10 sites, then you have to do it 10 times, right? With Terraform, the beauty is that you can replicate the code to any number of sites, right? Now, what is the expected outcome that we are trying to achieve? So at the end of this deployment, we will access the EC2 instance with the public IP, and the Nginx web page server should be displayed to us, right? This is the outcome that we are expecting. So let's go to the Windows 10 machine where we have the Terraform client stored, and let's work out this whole POC environment. So now let's go to the Windows 10 machine and apply the POC configuration through Terraform. So as you can see, this is the AWS console. If I refresh it, currently there is no instance store, and I am on the North California, which is US West 1. So before I go into the configuration itself, as we discussed before, that we have to deploy an VPC and subnet into Terraform. So let's write Terraform AWS VPC. So if you look at the first resource in here, so this is AWS VPC CIDR block. So this is how you define a VPC. So as I mentioned before, whatever you have to define, like VPC, I just opened the first link, and this is the command to define, or this is the configuration. This is how you define your VPC. Now, if you have to define a subnet inside a VPC, you write AWS subnet. And here, if you go and open this link, you will see the configuration template for defining a subnet. Right. So we have already defined the steps that we have to do. Now what I will do is that I'll open the Visual Studio Code. I'll open the folder in which I have put the configuration of my file. So this is the web1.tf, exactly the same way that like we created before. And let's go through this configuration one by one to see how we have done this POC environment. So the first part of this configuration is define the provider. So what we have done is that provider is AWS, profile default, you have done it before, region is US West 1, which is North California, access key and the secret key defined in here to access the AWS APIs. Now the next step we defined was to define the VPC. So we have already seen the template. So I have defined the VPC in here. The resource is AWS VPC and the name is Primos VPC. What is the CIDR block is 10.1.0.0/16. And I put a tag as well just to identify this specific VPC. Once we have deployed this configuration, we will go into the web GUI and we will check if the same VPC has been applied. So this is the name. Now inside that VPC we need to have subnet, right, on which we will deploy the POC server, the web server. So I have defined the resource AWS subnet. The name of the subnet is web subnet A. The VPC ID is AWS VPC. And this is the Primos VPC, is, if you look at it, is the name that I have derived it from in here. And this is all taken from the template, the configuration that has been given in the Terraform documentation. So AWS VPC, Primos VPC is referencing to the VPC that I have defined above, and .it. Now the CIDR block for this specific subnet I have taken as 10.1.1.0/24 as per our diagram, and I have also defined a tag which is basically the name or the identification. The web server subnet is the name that we can identify this subnet in the GUI as well. Now we add a subnet internet gateway. Now this internet gateway is required for the outbound traffic because when you create a VPC and a subnet, by default there is no internet gateway associated with it. So we have to define an internet gateway. So resource AWS internet gateway, as you look at this configuration, and the name is IGW, and VPC ID is the same way I have defined it before in the subnet. AWS VPC, Primos VPC is the reference .id, and the tag for this one is web server internet gateway IGW. Now I need to edit the route table. The reason of editing the route table is that I need to associate the default gateway with the internet gateway. So what I want to say is that if there is any outbound traffic, the route table should throw that traffic to the internet gateway. So if you look at it, this is a resource AWS route table web server 1, the VPC ID, we have defined it before as well. Now here is the route. The CIDR block is 0.0, which means all subnets. So traffic that is going anywhere, right? And the gateway ID is AWS Internet Gateway IGW.ID, which is the Internet Gateway I have defined above. So what I'm doing in this route table is that editing the route table to make sure that if there is any traffic that is going outbound, it is thrown to the Internet Gateway. Now, another step is to associate the subnet with the route table. So here I'm doing that. So resource AWS route table association, web server 1. This is the name. Subnet ID is AWS subnet, web subnet A. This is the subnet that we have defined when we were defining the VPC. And the route table ID is AWS route table web server 1.id. Right. So we are associating this specific subnet A to the route table web server 1. Right. Now, another step that we identified when we were writing the steps was that we need to have a security group, and this security group should have the feature where it should allow SSH and HTTP traffic, because both the traffics are required, one to access the web server and the other one to SSH to the EC2 instance, so that we can do the configuration, Nginx configuration. So let me highlight this configuration. So if you look at this configuration of the security group, resources AWS security group web server 1, this is the name, and we are creating a security group in here. The name is allow SSH HTTP. Description, just for information, VPC ID, we have defined it before, associating this security code with a particular VPC. Now in terms of the ingress traffic, what we are defining, the first block that we are defining here, this is the SSH traffic. As you can see, SSH works on the port 22, so we are allowing anything from port 22 to be allowed in. And CIDR block 000 means that SSH traffic from any IP address. So if we are anywhere around the world and if we SSH from a public IP, then we'll be able to access the instance. May not be the best practice, but this is just for demonstration. Now the same, I'm doing it with the HTTP. If you look at it, there's HTTP traffic. I'm allowing port 80, and the traffic can come from anywhere. So this is where when I'll try to access the server from my web browser, I should be able to see Nginx page. Now this is egress traffic. This is just 00 from any port. Define key to access the web instance. Now, as I said, that this is required because we need to access the EC2 instance to do some configuration. So you need to have a private and public key. That is what I'm generating in here. Define the key to access the web instance. So I have generated an RSA key with 4096 bits, and then I'm defining a resource AWS key pair web server 1. Key name is this, and the public key is, I've defined a TLS private key web server 1 public key open SSH, and this is also I'm taking it from the Terraform documentation. Now the last step is defining the web server instance. So in the web server instance, you have defined the web EC2 instance before as well. So resource AWS instance web server 1, this is the name. Key name, we have defined the key above. AWS key pair and web server 1 is the key name. AMI is this is the Linux AMI. Instant types is T2 micro, which is the smallest one. Subnet ID, we have defined it before. Here we are associating with this web server. Security group, we have defined it before. And associated public address is true, which means that a public IP address will be assigned once the launch of this server is completed. Right now, here is a specific configuration where we are building a connection with the EC2 instance. So once the server is up, what we will do is that this is a SSH type of connection where the username is EC2 user, and the private key that we have defined above I have configured in here. So with this private key, they will SSH with the username of EC2 user and this private key. Now the last step is the configuration on the Nginx to install the Nginx software, right? So this is what I'm doing in here. Provisioner, I'm provisioning remote exec inline, and these are the three commands that I will be using onto the Linux interface to enable the Nginx server, right? And the last, this command is for basically just displaying the the public IP address that will be assigned to the instance, that will be displayed onto the console itself, so that we can pick it from there, or we can go to the GUI of AWS and pick up that IP address and put it on our browser to see if this has been done. So let's begin our configuration. Let's start the Terraform init. This is the first command, so that all the relevant plugins are being downloaded for AWS. This is done. So I will do a Terraform plan just to make sure that there are no errors in this configuration. So as you can see, it is working on, and it has developed all the configuration. Let's see if there is an error, any error in this. So it's saying that there are 9 to add, 0 to change, and 0 to destroy. So there are 9 different components that will be installed in here, and there are no errors in the configuration. So let's go ahead and deploy that. Let's deploy. Sorry, Terraform is not deploy, it's Terraform apply, and it will ask me for a confirmation. I will say yes, and then it should start configuring it onto the, so I'll pray yes. I will stop the video in here because it will take like 1 or 2 minutes to do the configuration, so I'm stopping the video in here. So as you can see, the configuration is now complete. Apply complete, resources added 9, 0 change, and 0 destroyed. So let's go to the GUI and see what is being configured on the, so let's refresh that. So as you can see, there is a T2 micro instance that is being installed. It is still in the initialization stage. So in the meantime, let's go and check our security groups. So if you look at the security group, there is an allow SSH HTTP security group configured. If you look at the configuration and inbound rules, it is allowing HTTP and SSH traffic from any source. So this is what we configured. Then if you look at the VPC configuration, let's go to the VPC and check if the VPC with the same name and configuration has been configured in here onto the console. So your VPCs, so if you look at it, there is a web server VPC. This is what we, and then if we click and see the details, CIDR blocks, so this is the 10.1.0.0.16. this is the block that we defined for VPC. Let's go to the subnets, and if say we have server subnet, and this is the subnet that we defined, and this is 10.1.1.0/24. and let's go to the internet gateway and see if there is an internet gateway defined. So if you can see, this is the name of the internet gateway that we did. So there is an internet gateway defined and it is attached. And just go to the route tables to see, this is the route table that we edited through Terraform, and let's see the routes in here. So if you see, this is the local network 10.1.0.0.16 local, and then there is a default route that is being defined for the internet gateway. So it's rightly configured. Let's go back to our EC2 instance and see. Running instance 1. So let's see our instance. Let's see the public IP it has. This is the public IP. Let's paste this IP into the paste, press enter. So as you can see, this is welcome to Nginx on Amazon Linux. So this is the desired outcome that we were looking at. So now the server has been stored, and if you look at it, there's a lot of configuration that you can see in here, but this is a one-time exercise that you have to do to build this configuration. Once this is built, then the next time you just have to edit the variables to reach your desired outcome. Now the last step that we have in here is that do not forget to destroy your configuration, else you will be charged for the resources that you are running in AWS. So I'll just put Terraform destroy. It will ask me for a confirmation. I will press yes, and then all the resources will be destroyed. So you can see that how easy it is to provision multiple resources with a single command, and then you can destroy these resources with the help of single command as well. So with the help of versioning control, you can switch back to any of the infrastructure version that you have defined before. So I press yes, and now it will destroy the resources. So in the last part of this video, I just would like to show you some reference designs to emphasize the importance of infrastructure as a code via Terraform. So if you look at, this is one of the designs of WordPress deployment in AWS. So if you look at it, this is quite a complicated deployment in which you have a number of components in here. But if you develop this kind of an architecture in the form of a code via Terraform, so this will be one-time activity. Later on, if you have another customer that is willing to deploy WordPress based on AWS reference architecture, the same code can be replicated by changing the variables. So it makes your life very, very easy. Consider, just imagine that you have to deploy this whole infrastructure with GUI. How much time will you take? And if you have a ready template in the form of a code, how much time will it take? So that's the beauty of infrastructure as a code, that it makes your life very easy, and it's it gives you the infrastructure in a form which is easily repeatable. This is another reference design for disaster recovery, and the same principle apply in here, that it's a one-time activity to build the code for this kind of an architecture, and then you can replicate it for different customers. This is another design that's showcasing the same thing. So all of this can be deployed with the help of infrastructure as a code. And as we have just discussed about AWS, because we were discussing about the basics, but Terraform works equally well with Azure, with GCP, with Oracle. So you can use it with multi-cloud deployments as well. So if you look at it, AWS has CloudFormation, Azure has ARM templates, but is it worth really understanding CloudFormation and ARM templates when you have a tool like Terraform, which can work directly with multi-clouds? Because you will come up when you're working with the cloud, you will have scenarios where the customer would like to have a primary site into the AWS, and he wants to have a disaster recovery in GCP. So this kind of, you need an IaC tools that is multi-cloud supported. So Terraform is one of the most popular tool, and it's used in here worldwide, globally, very well. So it's important to learn Terraform. So this was a short video explaining the basic concepts of Terraform, infrastructure as a code, doing some basic configuration, and a case study to explain the concepts. It's just the beginning of learning Terraform, but hope you enjoyed the lecture, and thank you very much for joining in.